So example 2 says to use the given function to answer the following. So we're given y of x equals x squared minus 4x plus 4. So again, we should recognize that we have the required x squared term, and again we've got optional x and constant terms. So in here we should recognize this as a quadratic equation. And we're asked to graph, and so we know that, again, a quadratic equation, we should get a parabola-shaped graph. So we're asked to use Zoom 6, so that's going to set our standard window to run from -10 to 10 in both directions. Alright, so on the calculator, we are going to go back into y equals, and you can hit clear to clear off the previous function that was there. And now we're going to type x squared subtract 4x plus 4. And then it said, again, to start with Zoom 6. And so again, we can see that we've got a y-intercept here, and then for the x-intercept, we don't really know if maybe it misses the axis, maybe it touches just once or crosses twice. It kind of looks like it just has one x-intercept there. But again, we're going to look at the mathematics to see what's really going on for this particular graph. So if we're looking for the y-intercept, it's our output when input is 0. So if we input 0 for x, we're going to get positive 4. And so on our graph, we saw that point there. So this kind of came down like this. Kind of looked like it did this. Or this was at 0, 4. So it looks like it has just one x-intercept. It kind of looks like it comes down and kind of just barely touches the axis and bounces back up. So what happens if we use the quadratic formula to find the x-intercepts on this one? So again, to get an x-intercept means we're trying to find the x values when y is 0. So we want to solve for x in the following equations. We're going to put in 0 for y, so we're going to get 0 equals x squared minus 4x plus 4. So to use the quadratic formula, we need this to be 0, which it is. Again, our coefficient on x squared is 1. Our coefficient on x is -4, and our constant is positive 4. So if we plug those into our quadratic formula, x equals the opposite of b plus and minus the square root of b squared, again all these parentheses are important, minus 4ac all over 2a. So the opposite of -4 is a positive 4, plus and minus the square root. -4 times -4 is a positive 16. -4 times 1 times 4, we're going to get minus 16. And 2 times 1, we get 2. So 16 take away 16, we get 0. And the square root of 0 is 0. So in this case, we just get 4 plus 0 is 4, and 4 minus 0 is also 4. So we're just going to get 4 over 2, which is 2. Okay. So again, remember we were trying to find the x that we were going to put together as a coordinate pair here. So an input of 2 gave us an output of 0. So we do actually have just one x-intercept on our graph. Okay, so this x-intercept here is at the point 2, 0. So we can see we got just a single answer for x when this part under the radical became 0. So now it says to use the given function to answer the following. So now we've got f of x equals x squared plus 5. Again, we should recognize this as a quadratic equation. And we're asked to use our calculator again to look at the graph of this one. So again, we're going to push y equal. We're going to clear the last function that we put in there, and we're going to type x squared plus 5. And then again, we're going to start with the standard zoom, Zoom 6. And now here we can see our graph touches or crosses through the y-axis once, but it doesn't cross through the x-axis at all. So this particular graph has no x-intercepts. So zoom 6, our standard window runs from -10 to 10 in both directions. And our graph, let's see, our y-intercept here, output when input is 0, so if we input a 0 for x, we get 5. So we have this point at 5 and our parabola that went through like that. So we got this point at, input of 0 gives us an output of 5. So our y-intercept is at 0, 5, and we can see that there are no x-intercepts. So how many? It doesn't have any. So what happens in this case if we try to use the quadratic formula to try to find the x-intercepts? So again, we're asked to find the x-intercepts, which implies we are trying to find ordered pairs where the output is 0 and trying to find out what x values do that for us. So again, if we put in 0 for y, we get 0 equals x squared plus 5. And we want to solve this equation for x. Again, to use the quadratic formula, we need a 0 on this side, which we have. Otherwise, we'd have to move some terms around to the other side. A is the coefficient of x squared, which is 1. Okay, B is the coefficient of x. We don't have any x terms, so that coefficient would be 0. And then C is our constant term, which is 5. So now if we use the quadratic formula, we're going to get x equals the opposite of b plus and minus the square root of b squared minus 4ac all over 2a. Well, the opposite of 0 is 0. Okay, he's our only number who's his own opposite. Plus and minus the square root. 0 squared is 0. And here we're going to get minus 20. And 2 times 1 we get 2. So we're going to get 0 plus and minus the square root of negative 20 all over 2. Well, this piece, if we try to key punch on the calculator, so let's hit, so square root is the second function to the square key. So square root, and then in there we're going to type negative 20 and hit enter. And it tells us that it's a non-real answer. Okay. So this is not a real number. Okay, there's no real number that when we take it times itself that we're going to get negative 20. A positive times a positive is going to give us something positive, and a negative number times itself, so a negative times a negative would also give us a positive. So in this case, the equation 0 equals x squared plus 5 has no real solutions, which also tells us that the function f of x equals x squared plus 5 has no x-intercepts. So in solving these types of problems using the quadratic formula, one of three things is going to happen with this piece under the radical. So in our first example, we got a positive number under the radical, and we got 2 x-intercepts. In the next example, we got a 0 under the radical, and we ended up with just 1 x-intercept. And in our last example, we ended up with a negative number under the radical, in which case we ended up with no x-intercepts.